Alright, so today I want to talk about two different kinds of designs, two different videos if you're watching it on YouTube. So I'll talk about, the first one I'll talk about is hierarchical analysis of variance, which is, I'm going to warn you, you shouldn't ever do this. It's just something that I should tell you about, but I'm telling you about it so you don't ever design an experiment like this. Okay? So, our factors, our independent variables, are usually crossed with each other. In other words, all levels of each independent variable occur with each level. So every level of A occurs with every level of B, for example. Okay? And I mean, so, well, we can look at the example here, A1, A2, B1, B2. All levels of B occur with all levels of A. Okay? So I'm not talking about subjects. Subjects are often nested. We have independent group designs. They're going to be nested, and that's fine. That's perfectly acceptable. What I'm talking about here is the regular independent variables, not the sort of special independent variable we have, which is subjects. However, sometimes the world throws us some sort of curveball, perhaps a changeup, maybe a screwball, knuckleball, some sort of junk pitch, not a fastball. Not with the baseball analogies. Come on, check if he's texting me. Right there. Okay. My phone vibrates. I just figure it's John asking me something. He's in school, but it's the March break and he's here.
It's me.
Yeah, it's you. Yeah, hi. How's it going? Good. Okay, good. Great. Let's see it. What do you think of hierarchical analysis scenarios? You don't? Good idea. So sometimes those things are going to be different. Like here's an example, and this is a real example. This actually happened. A friend of mine was asked when he was in graduate school to help someone who was running a clinical trial analyze their data. And one of the things that happens when you're in grad school, if you're a psychology student, is you take a lot of statistics. You take more. So for those of you who are planning to go to graduate school, this isn't the end of statistics or analysis of variance. It's going to keep going, man. But the thing is, you get so good at it that you can kind of sell your services. So he was, and you can charge a lot of money. I did it. I charged people $200 an hour, and that was in the early 1990s. Because it's like, well, you don't have the expertise, and you have a big grant to run your clinical trial. Pay me $200 an hour. So, this actually happened to my friend Todd. There were 3 hospitals in Toronto that were testing out different drugs. There are 6 drugs, and there are 3 hospitals. But they didn't have, these are pain drugs for burn survivors. So it's kind of nice that there weren't enough subjects. It's, you know, it's kind of sad, but it hurts, I'm thinking, to get burned badly in a fire. So there are 5 burn survivors per group, and there are 6 hospitals. And you might say to yourself, well, then why care about hospitals? Well, because different hospitals have different staffs, you have to take that into account. They have different, the food might be different. There's all kinds of possibilities that would affect someone's recovery and how they feel about pain. So we have to include hospitals as a factor, as a variable, but they're not crossed with drugs. Not every hospital gets every drug. What they were able to do, these people who ran this clinical trial, was they were able to test the 6 drugs in 3 hospitals. So do you see the problem here? So what we have here is we have drugs nested within hospitals. It's crazy. This is not something, and you can see, I imagine you can sort of figure out right away, how the hell am I going to interpret this? It's going to be complicated. So in this case, things are quite a bit different. We have hospitals, and we have 3 hospitals. So we have 2 degrees of freedom for hospital. Drugs are within hospital. There are 2 drugs within each hospital, 2 minus 1, times 3 hospitals. So we get drugs are nested within hospital. Now, subjects are nested within drug by hospital interactions. They're not it's not subjects within drugs within hospitals. Right? So it's not S within D within H. It just doesn't work that way. Because as far as the subjects are concerned, I always think of it this way. You sort of look up, and what could you see? I see a drug at a hospital. I can't see over here, which is a bit of a blind joke. Thank you. So, drug hospital. Subjects are nested in drug hospital interactions. So our error term is going to be subjects within drugs within hospital. So this is going to be, Todd, my friend Todd, when he did his consulting, he said you have to analyze it like this. You can't just look at the hospital drugs, you have to look at the hospitals as well and take it into account. Now the nice thing is, of course, we have now separated the variance that's only due to hospitals, that's this, with the variance that's due to drugs within hospitals. So that's going to give us a little more statistical power, so that's a good thing. Right? That's a good thing. There's nothing wrong with that. So this is a case where this is going to be useful. It's usually in a field type experiment. It's the only place you can use it, or you would do this kind of thing. Typically what would happen in this case is somebody, if a student came to me doing their honors thesis and said, I want to do an experiment like this, I'd say, nope. Nope. You will get all levels of D occur with all levels of H, or all levels of A with all levels of B. I would not allow someone to do an estimate design. Yes, John?
Can you put on audio book?
No, I'm not going to put on an audio book. I'm much more interesting than most audio books.
Let's go with our global services.
Be quiet.
Okay.
Yes. Not everybody gets jokes, son. Yeah. Not unlike me, by the way. You inherited that from your father.
Let's add some power tools.
What's that?
Let's add some power tools.
Assassin? Did you say assassin power tools?
No, add some power tools.
Add some power tools to this?
Yes.
Why? How would you put power tools in this design?
You would make it look more interesting.
Oh, well, almost anything to make this interesting. There's some facts here. I realize how freaking boring this stuff is.
You're not in denial.
Yeah, so you're saying I should just have a couple of I don't know, power drivers now and then? That'd be kind of good. Maybe next class I'll bring one of those in. I can probably find power tools up on the
Jump on the chainsaw.
fourth floor, or a couple of chainsaws. You don't want the blind man with the chainsaws.
Yeah.
All right, so you can see that for our times, this is going to be a useful type design.
Does it make sense?
Or you can add techno music to this.
Okay, that's enough. Music, there will be music in the podcast. There's always music at the beginning and the end. Not in the YouTube video, but the podcast. So, like where that came in? So here's another example. This is making it a little more complicated. This isn't a real world one, this is just one I cooked up. So in this case, we've got something that looks kind of crazy. So we got, I just assumed 3 subjects per group, put that over there. So we have nesting as well as a within subject variable. Stop checking your phone when it vibrates, it's right there. So what are our within subjects variables here? And what are our between subjects variables? So what's the between? Or what are the betweens?
B is between.
B's between, sure, there's different subjects and different levels of B.
C is between.
No, C's within, look, because everybody gets C1, everybody gets C2. Right?
A.
A must be as well, but when we talk about B, can we talk about B on its own? We have to tell something, but we have to say it's B within A. Right? Because different levels, different different levels of B are within each level of A. You see B1 and 2 are within A1, and B3, B4 are within A2. You see that? So different levels of B are within different levels of A. So we have nesting of subjects, of course, but we also have nesting of variables. So the Yates order thing, it says order is, which sounds like a great word. It's not. It should be order is. Yates order is your friend. It's going to tell you how to do this between subjects within. The final bit of Yates order is to say that when we do between subjects within, we do the top of the hierarchy first. So we would do A before we did B. For between subjects variables are A and B within A. Our subjects are nested within what? A by B interactions, and then C is a within variable. Okay? So we have A, B within A, S within A, B, and C. And then we just have to list them out, get the interactions, and everything will come out perfectly. So do you understand the design so far? It's weird. No one would ever make an experiment like this. you have to get your mind to make an experiment with this. That idea.
How do you know that it's different levels of B within different levels of A?
Because look, B1 and 2 are within A1, and B3 and 4 are within A2.
Okay.
Just you gotta really look at it and say, how would I talk about B? I can talk about A on its own. I can say A1 and A2. I don't have to talk about B at all. However, I have to talk about A when I talk about B. I can't say, is there effect of B? I gotta say, no, it's B within A.
Oh, okay. Okay.
You see what I'm saying?
Yeah.
Okay? And I can help see what itself. That's easy. So it's going to look like this. A is the top of the hierarchy. We'll list that first, and it's a between subjects variable. So it's A, B within A. Now we can't go B within A by A. That would be weird. So we just go S within A, B. So far, this is easy. And then go C. C by A, C by B within A, C by S within A, B. Done. This is one of those cases, again, you wouldn't typically have a design like this. By the way, SPSS can handle designs like this. When you do use the GLM procedure, the general linear model procedure, you have to talk about the nesting, that's all. But it can be done. But you'll never analyze data like this at this university. Maybe if you go on to graduate school and do some weird field experiment, but at that point, say, my old stats prof said never to do this. Can we get more money so we can run the experiment properly? That would be what you want to do in this case, okay? And we're going to test everything with the thing below it that has subjects in it. A, that's very good. B within A, there you go. So it's an annoying kind of design, but it can be done. You should be able to go the other way too. I talked about this, about how on your final exam, I guarantee you there will be questions that have a design and give you the source of variation degrees of freedom table. There will also be questions like this. And this question is like, here's the source of variation degrees of freedom table, how do you get the design? Okay? So let's go through it. What's our between subject variable? What do we have? What's a between subject variable? What do we even have? Very impressive. Yeah. Yeah, right. You want to come up here while I lecture? Sure. Yeah, you want to listen? Okay. So, John, what do you think of the between subjects variables here? Is it B or A? A. That's wrong. B. That's right. Go back and sit down and lose. Yeah, well, I should. Yeah, well, you should. Yeah, why would you know that? Your sister knows it. She was my TA for a while in this class. Now, she's also 24 and older than you and been to university. But anyway, still in university. B's between, because it's between subjects within. Oh, that just gave away spoilers. A's the within. So now let's build this thing. How many levels of B do we have?
3. So
Correct.
wait, back up.
Yes.
So back up.
That's comedy.
So between is always going to be listed as our first independent variable then?
Yes.
That's
It's always like between subjects within. Yeah.
Oh. Like, oh.
Yeah. If I only had a light bulb, I'd put it over your head.
Seriously though.
No, seriously, that's part of this. It does that. That's why Yates did this when he came up with this.
So what if there was no between? How would that look then?
Subjects would be first.
Okay.
And there'd be no nesting of subjects.
Gotcha.
So, we got 3 levels of B. Let's erase this. Oh, I could have just left that. And how many levels of A do we have? How many levels of A do we have?
3.
Also, do all levels of A occur with all levels of B?
Well,
Yeah, because of the B by A interaction. It doesn't say B within A or something crazy like that, right? Guess I didn't really have to replace all this. Yeah, well, what's left? We have to list the subjects. So, subjects are within B. Different subjects get different levels of B. 1, 1, 1, 2, 2, 2, 2, 3 to 3, 3. Oh, how many subjects are there in each group?
10.
You're just guessing at this point, right? You just threw out 10.
Okay.
How many subjects are in each group? The easiest place to look is here. We have S within B, and that's going to be n minus 1
But let me go back to the formula.
times B equals, well, 9, it says there. And we know what B equals. It's 2, or sorry, 3. So 3n minus 3 equals 9, 3n equals 12, and it equals 4. Algebra. That's one way to do it. There's an easy way to do it too. You go, what, we got 9 cells, 36 total observations. Oh, it's got to be 4. That's the other way.
Oh, you could start with that.
Yeah, no, but this is actually how, the design can get so much more complicated that that's actually probably easier.
If you're like, I haven't done that in a long time.
Oh, come on, you can do that.
Maybe if I think about it.
Yes, you can. Any monkey, a trained monkey can do algebra. I mean, you can be a pretty well trained monkey.
Dave,
Yes,
so total would be 36.
36 observations.
Okay.
We got 9 cells.
Okay.
36 divided by 9 is 4.
10, 4.
That's
So it's got to be 4.
Okay.
Yeah. That's one way to do it. In fact, I would do it both ways. In fact, when I used to do these kind of problems,
Oh, I understand.
I would do both. I'd do the algebra, but I'd also do that just to double check that, because if they disagree, one of them is wrong. So I better make sure.
3 levels of use, so 6. But no, I get it because the interaction.
Right. So this is, in a couple of weeks, I will set up a study group on Facebook to exchange questions, and I'll also put questions and answers in there. There's no rush because our exam isn't until, what is it, like the 30th of Brumiere? Anybody get that reference at all? 15th of Brumiere. No, it's the 19th of April, yes? That's a month. That's literally more than a month away. So I don't think there's going to be any traffic yet. But in a couple of weeks, I'll set up a Facebook group. Okay? And you'll have a lot of examples in there. Okay. So, things to remember about these. Oh, Joe, you got a question? You good? Okay. So, using Yates order, you can figure out any design in the error terms. That's the first thing to remember. We've got a little problem here with these hierarchical designs. Is hospital a fixed factor or a random factor? Drug, we're going to say is a fixed factor. We can say that, that's fine. Hospital seems a whole lot like subjects to me. And in that case, the expected values all go out the effing window. You can calculate them. It's doable. And in fact, in a really good graduate level stats book, there are tables at the back telling you how to calculate expected values, and it's doable. Except that doesn't sound fun. So the error term part is going to make it get a little more difficult, conceivably. So is hospital a fixed or a random factor? I don't know. I can make an argument probably both ways. So I just avoid these designs like the plague. They're no good. They're very, very bad. Also, what's your final result? Let's say you get a drug effect in that experiment. Drug within hospital. What does that mean? It means the drugs within hospitals are different from each other. Oh, notice how I had to say within hospitals. So I got to talk about the hospital too. That's not what the drug company wants within the study. It's not the interaction they want, it's the interaction they need. But, point is, these designs are really hard to interpret, so don't do them. Just don't do them. Okay? Questions about that before we move on and talk about Latin squares? Good? Just, don't. Just don't. All right.